we start now. Thanks for coming. The main purpose of today is to explain some possible use of the Saccade Vision product. Very shortly, we are speaking about a system with the 4 cameras and one laser that can go in 2 orientation. And if you look at the website of Saccade Vision, they speak a lot, let's say, from the point of view of metrology company. Today, I'm speaking from the point of view of an automation company. So, and especially from the point of view of someone who wants to define a process as far as possible by software. So, since the first moment we engaged with them, we saw possibilities to leverage their technology to get better automation products. Um, the first characteristic is what you can see in the video I was showing before. It's a sensor that scans without equality, but you can subsample the area and tell the sensor to look only in a specific place. And it's very easy to understand that this is an advantage for, let's say, uh, flexible automation. Now, let's talk about the 3 things we see as peculiar possible applications. So, first information, all the data of this webinar and also the previous one and also the next ones. Next week, we have one comparing different 3D technologies, let's say on large volume for beam picking. And all the point clouds and so on will be released on industrialrobotics.org, where we release a lot of things. So you can have information about setting up robots, and it's all for free. The first application is metal sheet connected. So one problem with the metal sheet industry is properly both angle and flanges. And when you do this, this is all the products I'm showing are not the real product of the real customers, because I have a room full of NDA, as probably 90% of the people connected working for the automotive and so on. So the idea is with this sensor, you can scan and have a high quality even on reflective parts, and the result is um, a very accurate measure of angles. And sorry, this is the problem I was saying before. This is my first time with this interface. Okay, measure and also distances between planes. There is a very high reliability of the point cloud. This is the only case where somehow we are pushing one of our product. We are developing a set of tools to do automatic measuring of metal sheet, both with the robot and without the robot, because it's a large industry with a very hard consistency in measures when it's done manually. And I want to show the point cloud on Cloud Compare, so you can download it to show one detail. So this is a single scan. You can mount multiple scan. The nice feature I want to show you, I don't know how it is visible in transmission. Can you see here? There is a kind of line, and there is here another one. They're very hard to spot on the real object, but what they are the sign of the die where the part was bent. So this is a real feature of the part. This depends on the tool used to bend the part. The quality of the point cloud is so high we can even detect this kind of thing. So first application is metal sheet. If you work in that industry and you have to make the process consistent along different parts, this is a great tool because the flexibility of the area makes it possible to measure all the different shapes, and the quality even on hard surface gives a great result in general. The second application is an assembly problem. Very clear. We stated the problem. So this is a spring. What you cannot see is that it's full of graphite. And the normal problem you have in many of the problems in the automation is that the spring has to be pushed somewhere, and you need to check the height to be sure that it's in correct place. This is a kind of problem that you may have, for example, assembling the door lock of in the automotive industry. And the smaller the spring and the harder the spring, the most complicated the problem is. So if you take a picture from the top, which is the only case you can have in 2D, it's, I will say, impossible to evaluate properly the height. This is normally handled by multiple sensors. So they try to have distance measuring and other technology and double check all of them, or an indirect checking, like it looks longer because it's closer. Very hard, while it's uh, really easy to spot the proper data in, if I can share the screen, in the point cloud. These will be also shared. Oh, magic effects, sorry. If you look, this is the data you can acquire with a single scan, so a pretty fast one. And you can appreciate at 0.3 millimeter move pretty easily. What we are looking for is check that these and this part are in position. If you consider that in modern lines, there are 3 to 7 models of different car locks, for example, that you have to check in the same line, the composition of the flexibility of the tool and the quality of the zeta, uh, whew, sorry, of the zeta resolution makes it a perfect tool. It saves a lot of time in setup. And this is an example where the spring is bent, okay? And you can see that on this part is always very clean, okay? So the second application we are dealing is assembly, when you need to check the zeta of small details, flexible items. So the hardest to locate normally. If you have other stuff, you can use the same sensor. What you're saving here is the complexity. You are reducing a lot the complexity of the analysis. Okay, one more consideration is occlusion. So this is one of the first reason we started using the sensor. When you have to check an item, camshaft, for example, or something that you need to be very detailed about, but you also have to, let's say, look in all around 360 degrees. The problem is, if the easy solution is to scan in triangulation and go um, for a rotation of the object. So you move the object. Long story short, you don't want really to move the object. It's always a uh, in theory it's very easy, but in practice, when you have a trouble, it's the kind of thing you don't want to troubleshoot. So in this case, you can use the fact, as you have seen in the video, that you can scan with two different directions, and you have four cameras. So you have one scan direction, the second one, and you can mount them. We replaced several, well, actually two rotation systems are already installed. Two systems that were done before in rotation and triangulation have already been replaced. In the setup time is a lot less, and the calibration time and quality is a lot improved. You can uh, double check these in the point cloud we will publish, because we are going to see this. So this is one, and it's missing, let's say, left, right. This is the same scan in the other direction. You're missing, let's say, north, south, and before it was west, east. And then when you see both together, you have all the data you need to perform a full inspection. So as promised, in 15 minutes, three very unique approach. So with a single sensor, all of them, you can arrange them with special stuff, but this is flexible and let's say, how can I say, you don't need to set up a complex system. It's all in one. I add one little thing. If you need to inspect something shiny and that it happens to appear in real 3D configurations, something stupid with live stream. Okay, I was saying something pretty shiny. This is metal worked. This is not the real part. The real part is steel with the lubrificant on the top, and it came in multiple setup, as you can see in the screen. This representation, we need to connect the same, more or less the same part, the different connectors at different height, and we want all of them to be inspected. Really, what we do here, we are locating it to permit to give the robot the possibility to assembly the wiring automatically. We have here all the advantage of being 3D, plus the fact that whatever is the angle, if we mount the two different orientation, we have always a very, very reliable full surface, so we can go for the circle easily. So the fourth, one more application, let's say a plus one, is if you have an assembly process and you want to drive the robot and you need to locate objects in 3D, even when they are shiny, this is much easier than uh, using a 2D, multiple 2D, and let's say more effective than a standard multiple fringe uh, sensor, because if they are shiny, you only scan the part that you want to see with a kind of redundancy, so you can get a good result even in that cases. As promised, I've been short, first time in my life, but you can ask any question if you have some of the moment. This video will be recorded because the main purpose actually is to have an introduction for the automation of this new technology. If someone has a question, I will be happy to answer. If it is too technical, I will ask my friend Alex to support me. It looks there are no questions, or I don't know how to use the system. Okay, so I close the session by showing again the first, let's say, feature of the sensor, which is you can scan locally. And I want to thank everyone for attending, and anyone in the future downloading the sensor, the webinar, and taking interest in this new stuff.